everybody. Hope you're ready to flex those brain muscles because today we're going to rationalize some denominators. So first of all, what does it mean to rationalize a denominator? It is simply to get rid of all irrational numbers in the denominator. You want the full denominator to be rational. And in this case, the square root of 3 is an irrational number. It can't be expressed as a fraction. It's an infinite, non-repeating decimal, right? It's an irrational number. So is the square root of 5, so is the square root of 2. These are all irrational numbers. And what we want to do is we want to get rid of all these irrational numbers in the denominator. We want our denominator to be only rational numbers. Why? Just because it's convention, it's nicer, it's better form, better practice. It's kind of agreed upon in the math world that, okay, when we have denominators that have irrational numbers, we always rationalize them. We want our denominators to be rational. It's just convention. So we're going to learn how to do it. Let's see, 1 over square root of 3. So how can I get rid of this radical in the denominator? And you may think, okay, well, to get rid of a square root, I can square, right? To reverse the square root, I can square this. So what if I square top and bottom? Well, the problem with that is if you square top and bottom, you're actually multiplying by 1 over square root of 3. But we can't do that. We can't change the value of this. So we want to keep the value of this the same. So if we multiply by something, it has to be some form of 1, right? So what we're going to actually multiply is square root of 3 over square root of 3, because that will still get rid of this radical in the denominator. And we'll be left with a radical in the numerator, but we're not worried about that. All we're worried about is we don't want radicals in the denominator. So this actually becomes square root of 3 times square root of 3, which is just 3. And this is root 3 at the top. All right, so in general rule, there's a general rule where if you have a single radical in the bottom, you can just multiply by that radical over itself. So let's try it again in this example. Square root of 5 over square root of 5. And these 5's on the bottom. Square root of 5 times square root of 5 becomes just 5. So we've rationalized the denominator. And on top is just 2 times square root of 5, which we just write as 2 root 5. All right? So these are good to go, but now the example gets a little trickier, okay? So what if I multiply top and bottom by square root of 2, right? What would happen here? I'd multiply this whole thing by square root of 2. I'd have 6 square root of 2 in the top. This radical we'd get rid of this radical, but then we'd have 3 root 2 here. We'd still have a radical in the denominator. So we use a little trick with these where they have 2 terms in the denominator, right? This is a binomial in the denominator. We have 2 terms, so we multiply the top and the bottom by something, and this something is called the conjugate, and you're going to use this a lot throughout the rest of your math career. You're going to use this. So the conjugate, and what it actually is you keep this the same and you keep this the same, right? So it's 3 and root 2, and you always just take the opposite sign of what's in the middle. 3 plus root 2, 3 plus root 2. And we'll see how this works in a second once we work it out. So I'm multiplying by this whole thing. All right, so I have to distribute this 6. So this is actually 18 plus 6 root 2. 18 plus 6 square root of 2 over, let's see, this becomes what, 9. But look what happens here. That's 9, and that's plus 3 root 2. And then minus 3 root 2. You see that? How those radicals cancel? And that's why we use this conjugate, is because that happens when you use the conjugate. The radicals cancel. So this is 9 plus 3 times root 2 minus 3 times root 2. Those will cancel. And then it's minus root 2 times root 2, which is just 2. Right? And then when I simplify this, it is simply 18 plus 6 square root of 2. Over what, 7. And again, I could factor out a 6 from the top, but it wouldn't help. If it would help me cancel this denominator, then I would do it for sure. Maybe if the denominator wasn't prime, I would do that and try to. But yeah, this is as simplified as it gets. So we're going to use the conjugate a little bit more in some more examples. All right, let's do a few more examples. This time we're going to throw in some variables. We're going to introduce x and see how it's different. Okay, so it's actually not any different. I can still multiply by square root of x over square root of x, and that'll still get rid of this radical in the denominator. So it really doesn't change when you introduce variables into this. It's still the same thing. Square root of x over square root of x. So this is multiplying, so I'm end up with 2 root x over x right? Still the same idea. We just have a single radical in the bottom, so we're just going to multiply top and bottom by that radical and get rid of it. So we've rationalized this denominator. So let's move on to this one. I see two terms in the denominator, so what jumps out to me is conjugate, right? We're going to use the conjugate. So basically what I'm going to do is multiply by 2 plus 5 root x. All I do is I change the sign. I keep everything here and here the same. I just change the sign. Over 2 plus 5 root x. Alright, so this is multiplying, so I need my parentheses because this 5 distributes to everything when I multiply. And here I need parentheses too. This is going to end up foiling, right? So I have, let's do this top first. 5 times 2, that gives me 10. Plus, how do I multiply this with this? I have 5 times 5, that's 25. And the root x just chills there, right? 25 root x over. Alright, now the bottom. 2 times 2, that gives me 4. And remember what we said about this conjugate? It's going to end up canceling these radical terms, but let's make sure that this is correct. 2 times 5 root x, that's plus 10 root x. And I'll write out every step because I didn't do that on the last page. So plus 10 root x minus 10 root x. And now you can see, you can fully convince yourself that these cancel. And now what's the last term? Let's see. Minus 5 times 5 is 25. So that's minus 25. And then root x times root x is just x. So I can actually get rid of this plus 10 root x minus 10 root x. I can get rid of this. Right? These can both go. And I'm left with 10 plus 25 root x over 4 minus 25x. So let's rewrite this. Let's see if I have room. 10 plus 25 root x all over 4 plus, minus, right? I know I have a plus here, but that's part of what I canceled with this 10 root x. Minus 25x. Let's see. Can I factor anything out and cancel? I could factor a 5 out here, but it wouldn't be able to cancel with these. Remember, since there's 2 terms on top and 2 terms on bottom, I need to, if I factor something out and cancel, it has to be a common factor of all 4 of these, right? So in this case, this doesn't have a factor of 5, so the 5 would not help me. So I believe this is as simple as this will get, and we're good to go. So let's do this last example, and let's see. In this case, conjugate does jump out to me because we have 2 terms in the bottom, but both these terms are radicals. And all these other examples, only one of them has had a radical in it. So let's see how this is different, and let's see if our conjugate still works. I think it will. So again, root x, and I just change the sign, plus 2 root y. In this case, I have 2 variables as well. So root x again, plus 2 root y. So I'm using the conjugate. We're going to make sure this works. So in this case, on the top, I simply just distribute this 3. So this equals 3 square root of x plus 6 square root of y. And on bottom, what am I left with? Let's see. These need some parentheses. I'm going to do some foiling here. Basically just multiplying 2 binomials. Okay. Square root of x times square root of x, that gives me x. And look, that radical we already got rid of that radical, I think. Square root of x times 2 square root of y, that's plus 2 square root of y square root of x, basically. And I believe this is going to end up canceling when we do this next term. Minus 2 square root of y square root of x. Yeah, so these are going to cancel. And what's that last part? Minus 4y. Y'all see why I got that? 4y. 2 times 2 is 4. Root y times root y is y. So now these middle terms still cancel. These are gone. And I'm left with what? 3 root x plus 6 root y. So 3 root x plus 6 root y all over x minus 4y. So in this case, it did still work for rationalizing the denominator, even though both the terms in the denominator had radicals in them. So this conjugate still works in those cases. And if there's different variables, it doesn't matter what it is. Whenever you see 2 terms with radicals in them, it should always jump out to you, oh, I need to use the conjugate here, and you should just go straight into doing that. So hope this video helped. Leave a like below if it did. If you have questions, you can comment those below as well, and I will answer them. And until then, keep making those brain gains, keep flexing those brain muscles, and I'll see you in the next video. Thanks.